Ladies and gentlemen, we are broadcasting live from the MR headquarters, and I would like to remind what we are doing here. The last 2.5 days, MR was presenting its first digital event, a combination of live presentations, expert communications, and customer interactions. Altogether, so I have already asked for the figures, we have counted more than 2,500 online visitors to our event, which is a great success. And our goal was to reach out to you, our partners in business, under the headline, Enter a New Dimension of Reliability. We brought new products to you, and more important, the exciting aspect was to bring this product into a sensor network to show their interaction, to generate benefits of digitalization. We as Reinhausen Group are your solution partner for power transformers, and we are providing and processing all the physical and chemical parameters for long-term and safe operation. For our final round here, for our roundtable here, we have invited two special guests to our studio here in the Co-Creation Center, and I would like to introduce Wilfried Breuer to you. He has been in the management of TenneT, the large European grid operator, for more than 7 years, and before that he was working also very actively in the field of technology at Siemens, and he was joining MR in April 2019. The second colleague, Karsten Viereck, he got his PhD at Dresden University, and he was for more than 12 years working with a German transformer manufacturer, so he has the experience from the OEM. He introduced the first monitoring system for power transformers on the German market, and MR was hiring him in 1997, and since 10 years he is head of the development for electronics and introduced also power electronic solution to the MR portfolio. Now he is director of our automation unit. Wilfried, Karsten, what was the most remarkable topic or even session we have seen in the last 2.5 days? I think Carsten should start.
For my opinion, the worldwide introduction of the vibroacoustic monitoring module was a very exciting point. Vibroacoustic offers the possibility for data mining also on the transformer and also on a tap changer. And so we have an open space for future investigation on the transformer and also on the tap changer. Also that means data mining, that means cloud solution. All these important things are possible based on the vibroacoustic monitoring module, short VAN, what we have now on the market.
Yeah, Wilfried, maybe we can also get your view on the topic.
Yes, I would like to add the bushing monitoring, online bushing monitoring to the highlights, as it is a known area of concern. It is difficult to monitor offline, takes a lot of efforts to perform the tangent delta measurement in the field, and having that permanently online, I think, is a great contribution to the reliability of the asset operation.
Yeah, thank you very much. Our participants of the digital event were extensively using also the live chat function, and so we got a lot of very interesting questions and remarks, and my duty for the final session here was to generate own questions. So as I'm an electrical engineer, so I always invest a lot of brain work to be lazy at the end, so therefore I took all the questions from the chat, and yeah, the next question from the chat goes into the direction in which way we can differentiate the meaning of sensors, what means intelligent sensors, and in which way network transformers mean communication. Let's start with sensors. What should be the minimum installation of sensors in a power transformer? which is, to my understanding, always the most valuable component in any substation. Maybe Carsten, as the sensor expert, you can start again.
Yeah, we will have a standard fitting of sensors on the standard transformers. You will find a temperature measurement, you will have oil level gauges on the transformer, and also a Buchholz relay. That's the standard solution you will find on every transformer. And the big ones also on the step-up transformers and also on phase shifting transformers. What comes up now is, but we will have digital sensors and for the measurement also of temperature, also for the winding temperature, for instance, the optical fiber ones, and so on. And in future we will replace these conventional sensors with digital ones, because they make it possible to have a data concentration also and an evaluation of data, so that we combine it with the ethos system, for instance, as for the data processing also. That's the control unit on a transformer. And they will be connected by the sensor bus system directly also to the ethos system, so that we can have an overview about the condition and the measurements on the transformer online and also for cloud solutions.
Yeah, Karsten, now you have fulfilled my expectations. You have named all the sensors. Therefore, Wilfried, my original question was, what is the minimum amount of sensors or the minimum installation of sensors we should have on transformers, especially critical transformers in the power grid?
Yes, from background of operator, I would say the operator has to define what sensoring is covering his pain points most, to avoid sudden outage of the asset, sudden unavailability, and allows preventive maintenance. So I think the definition, what is the minimum level and which ones to go first, should be each operator based on its own operational experience, as a selection out of our offering.
Yeah, so I think that also shows the potential ways the market can also react on the different offers. Now, I would like to come to a question where I also have a personal interest in when we're talking about sensors. So a sensor as such is transferring a physical quantity into a signal. And that's our raw data. Some sensors might have also some intelligence on it. So this is the intelligent sensor portfolio we have presented the last days. And I can already then transform data into information. And for me, the question is, what will be the development? Will we have only intelligence sensors in the future? Or what will be the perspective? Maybe Wilfried, you can start,
Yes.
because it fits a little bit also to your answer to the last question.
Yeah, I hope so. I think the sensoring needs to add benefit and value to the operator and asset owner. Therefore, the choice where to apply intelligent sensors in the future should follow the sensitivity and the expectation and the needs of the grid operator. Therefore, the grid operator needs to make his own choice where intelligence adds value and where maybe a straightforward conventional sensor is sufficient to do the job.
Yeah, so there the question to Karsten, because you have a long track record in bringing intelligence to the sensor as such, and I know that you have invested a lot of brain power, manpower to come to the solutions. Do you still see also conventional, a value of conventional sensors on the transformers as well?
Of course, we will have conventional sensors on the transformer, like to measure the oil temperature of a transformer. It's only necessary to have the PD100. Maybe the PD100 sensor will have a digital interface, of course. That's one. But the new generation of sensors will have the ability of pre-processing of data, and that's to get the information, not only the raw data, but to get the right digital information from the physical part of the transformer, maybe the bushing, so that we are able to calculate the dissipation factor, for instance. That's a very important fact here. Or if we go to the optical fiber ones, then you have every time you will have a controller inside which is able to calculate the data and get the information and send the information also to the ethos system as a data processing unit there. And that will be the future for the next sensor generation. And all these sensors we can find now in the ethos system direct on the transformer. And that's also the point that you can retrofit these solutions for all the transformers in the field.
Yeah, so to summarize that, you also see a perspective of conventional transformers maybe equipped with this digital interface, and also that will also enable then the retrofitting of the transformers.
That's also the part. You will also find a dial-type thermometer on a transformer because it don't need auxiliary energy. But for the new data pool you want to have now from the device, it would be necessary that you have a digital one there.
Yeah. That leads me to another question from our chat function. There's a certain criticality behind that, because it's asking, when we are looking on the installed base of the power transformers in the grid, how long it will take in average to equip all of them with this new kind of sensor. So therefore, first I would like to ask Wilfried, so is it really necessary to equip all transformers in the grid with sensors, or should we not concentrate on the critical ones?
Yes, Uwe, thanks for the question from the audience. I share that view. It depends on the criticality, and probably the only true answer is here that we will never see 100% penetration of the installed base of all transformers globally with intelligent and smart sensoring. There is a huge fleet installed with a different background of age, manufacturing, function in the grid, and their contribution to security of supply. So I do expect that the sensoring is first, intelligent sensoring is first applied where the criticality or the value of the transformer is highest to the grid operator. And then it will take its certain speed to cover a rest of the fleet. Most importantly is that our solutions can be retrofitted, and it's not always the size of the transformer which determines the value or the criticality for the operator.
Carsten, you like to add?
Yes, it's strongly recommended to fit digital sensors directly in the transformer factory on the transformer. But in the field, on every transformer, if it is necessary, you will find an empty thermometer pocket, for instance, or a flange for a DGA sensor, for instance, that you are able to retrofit also sensors, digital sensors, and ethos system on a transformer in the field. And for my opinion, it takes 2 or 3 days for retrofitting such a device, also in the field.
Yeah, so now I like to add a personal question, because as I have a certain background on the distribution grid, what is the opinion towards primary distribution transformers? I think we can exclude the secondary side, but for the primary distribution side, there we have also a kind of criticality in the system, and with the integration of renewables, the Energiewende, energy transition process, more and more these kind of transformers become a completely new criticality.
Yes, of course. Thank you for the question. That's an interesting point. Because I think, in my opinion, we will find in the distribution level, for instance, in future, for instance, simple DGA sensors, like the MSENSE 3, for instance. That will be the new topic for also for distribution transformers to detect a malfunction in the active part of the transformer, and also the other ones. What we have in our range will also give additional information about the condition in the distribution level. And if you see what happens in the distribution level, the increasing level of renewables, for instance, then we will have a changing load on these transformers, and so the overloading of such a transformer will be a very important point in the future, I think. And for that, to give an overview about the condition, it would be necessary that you have more sensors also on distribution transformers.
So what is the opinion from the grid operations side, from the transmission side towards the primary distribution? I think there is also a certain kind of interaction necessary in the future.
Yes, I share that view. The transmission level has traditionally always been equipped with a higher level of sensoring, measuring data, and make them online available to the control and dispatch center. With the growing importance of the distribution level also as an in-feed grid for the renewables, which are mostly connected not at transmission but first to distribution level, of course the need for increased transparency on the health status of the assets and the operational status becomes increasingly important in the distribution voltage level as well. So I fully share that view that probably the highest growth rates of intelligent sensoring we rather see actually on the distribution level.
Thank you very much. Now I would like to switch over from the pure sensor hardware point of view more to the data view. So when we go down the road from sensor data via transformer information towards operation or asset management decision, data handling becomes really important. And here we always have to ask ourselves, what will be the winning solution? On-premise, cloud-based, or both? So maybe, Carsten, I would like to start with you as with your sensor solutions, you're generating a lot of data.
Yes,
what should we do with them?
Generate information, I would say, from the raw data. I think, in my opinion, we will have both. It depends on the application of the transformer. Also, if we have a phase shifting transformer, we have different tasks for this kind of very important transformer. Or if you have a step-up transformers, you must be able to have data pre-processing direct on a transformer. And ethos, maybe it's the basis to have this information pool directly on the transformer. That means it is necessary to have it on-premise on a transformer to get the information there. And we have also modules from the monitoring system which have the same task like a protective device to give an overview about the condition of the transformer. So also we have a direct data transmission to the substation control system, for instance, like the dynamic transformer rating for very important transformers, for instance. And that will be the next step in the monitoring system, not only to generate data and information, sondern have an interaction with the substation control system, for instance. And of course, you will have the conventional one, sensors or sensors which put data into the cloud system, and that's important to have information for the asset management, for maintenance topics, whatever. And that is based on the sensor data which we send into the cloud and have the system and the evaluation of data in the cloud system. From there, like we can use it in the FleetScan 2D system, for instance, to have an overview about the health index of a transformer, to calculate these information to plan maintenance action in a transformer fleet, for instance.
Wilfried, your perspective, on-premise, cloud-based, or both?
Yes, Uwe, before I answer that question, I would like to clarify with, let's say, from my grid operation experience, that there are different applications and use of the data at an asset owner and grid operator. The first is the system operation of the grid, the system operation of the transformer. This is real time. There, the data has to be transferred to a control center. Nowadays, control centers are very efficient, and there it is very important that the data is safe, secure, and also condensed, that the operator, which operates usually a large grid, a big fleet of assets, only sees the relevant data for the current status of the grid operation. The second use of the data in a grid operator is asset management functions. When do I perform maintenance? Which frequency? Where do I do preventive repair to avoid unscheduled outages? This doesn't have to be real time. This is usually evaluated during normal working hours by engineers in the office. So we first have to differentiate these two applications of the data, which of course should be sourced from the same sensors in the field. There's no need to duplicate sensoring in the field for the different applications, in my view. That just increases failure rate and unnecessary duplicates sensors. So that to be explained. Now, to answer your question, clearly we need both. We need to be ready for cloud, because the cloud offers more efficiency, but at the same time, of course, cloud-based solutions, especially public cloud-based solutions, will always have a higher vulnerability towards cybersecurity. So we do need to respect that certain operators will decide for on-premise solutions, will keep especially the operational real-time data strictly on-premise or in private clouds. So our offerings and solutions have to accommodate always both choices. And it's not a choice which a client or an operator takes for each and individual asset. It's a corporate choice either to do it that way or the other, and we need to be ready for both. I think there is not either or, there will be both for at least the next decade to come.
Yeah, I would like to stay with the topic, and you mentioned, yeah, we have to be, and I would like to reformulate the question to Karsten. Are we not already there? Because with Ethos, we can use Ethos also as the redirection function towards operation data and asset management data with different time perspective.
Yes, we have, I agree. We have both perspective on the Ethos. We can also have information about the condition of the transformer, and also we have the information for the asset management in the Ethos ready for transmission. And we have data and information that you can store directly in the Ethos system, and asset management can use it, can download the data, or you can transmit these data into the substation control for operation of the transformer. Very important issue is here, in each case, in each use case, that we have the focus on cybersecurity topics. And also for cybersecurity, we are well prepared now to have the right level for the utilities, to have a safe data transmission there, and so that we can go in the right direction. And what's now is very also under discussion is the evaluation of the transmission protocols, like the IEC 61850 for the third generation of third edition, so that we will find the new information, logical nodes also in these protocols, prepared for the next generation of the operation of equipment in the substation. And it's also combined directly combined with cybersecurity issues here.
Yeah, so that means we can then also deliver solution to different markets for different perspectives.
Uwe, I would, sorry for,
yeah,
I would
please.
really like to say we are there. We do
yes.
offer the solutions for the on-premise as well as for the cloud-based. So the evaluation, and Karsten named it FleetScan's 2D condition monitoring and health status evaluation tool, We can evaluate the data from a cloud of the customer if he shares the data with us, but we can also offer the tool that it is performed by the client and he retains data what he deems critical by himself on-premise. So we offer already today both solutions, and when I meant in the future we should continue this duality as Reinhausen Group, that all the solutions in sensoring and data-based business models we are offering should be always suitable for both on-premise as well as cloud-based.
Yeah, thanks for the clarification. Yeah, that was exactly my intention by handing over to Carsten before. Now I would like to change the perspective, because in the moment we were going in the direction to be very excited about technology. And now I would like to turn the perspective towards the customer's view. And the question here is, what are the benefits for operation and asset management to have sensors installed, information of the conditions of the transformers collected and prepared for decisions, either operation or asset management? Wilfried, I think this is a question which goes much more in your direction first. I think I have some side questions to Karsten then based on your answer as well.
I've seen that coming, yes. Thanks, Uwe. Clearly, the sensoring has to add value for operational performance and asset management to the asset owner. Current practice in many utilities is that transformers are evaluated and measured maybe on an annual or on a biannual basis only. Oil samples are taken and probably a tangent delta measurement is taken even more randomly. Therefore, it does not very often, but occasionally happen that transformers fail in the field unscheduled without much warning. The sensoring offers a continuous monitoring of the health status, so much earlier we get aware of certain criticalities. For instance, deterioration of the insulation level inside of a bushing can be due to water ingress or humidity, and long time before it leads then to a fatal accident and potential loss of the asset. The asset can be taken off operation on a scheduled basis. The bushing can be replaced, just taking that as an example. Not every failure, of course, on the transformer is a bushing failure, but just staying with that example, and allows then for a much more reliable operation in the future. So that is, in my view, the great advantage. You can compare it maybe also with the car. In the old days, you had an oil level indicator and you had to open the bonnet to see what is the oil level in the engine. Today, you get it online, so you get it before you actually have an engine failure if you forget to do it regularly. So it allows the operator at the end of the day also to have a rather event-based maintenance and repair rather than on a fixed time base, which also enhances service efficiency and asset management efficiency. So it works in both directions, operational reliability and more efficient service.
Yeah, there's a good reason why we have also a special view on the bushings, because the CIGRE studies show that there is a certain higher criticality for this kind of components, for sure. That's why we have also sensors for that.
But Uwe, as we also serve bushing manufacturers with our insulators, I wanted to avoid the image that we see bushings as the, let's say, the fuse of a transformer. So therefore, yes, the CIGRE statistic shows that, but failures on transformers are, of course, due to multiple root cause.
Sure. And the root cause is not always mean the component as such. It could be also missing services, not done services. So we have there also examples for tap changers not getting a service, and
that's not
also running.
That's as Reinhausen not
excluding that. Yeah, exactly. So we should there be very open. Carsten, going into the direction, so as well, what can you recommend as a customer benefit out of the specific solutions. I think we have discussed the vibroacoustic sensors. We have the bushing monitoring. So that's why we also have the vibroacoustic sensor there as well for the tap changer. So maybe you should not focus on the bushing so much. Maybe we can put the focus on the vibroacoustic, a short one.
Vibroacoustic offers a new field of investigations on a tap changer, of course, for the function of the mechanical part, but it offers only a wide range for the data acquisition, also from transformer data, to combine it with monitoring data from the ethos directly, so that we are able to have an information about the active part together, vibroacoustic with a regression model, and also combined with monitoring data. And that's one of the future topics what we will have in the next time. And what I want to underline on the other way is we had in the last months much discussions with utilities also, that we are able with the ethos system to calculate the health index for a transformer. To have a precise answer for a question coming from the asset management: how is the health of the transformer, of the not only the bushing, not only the tap changer, about the whole equipment, for the to put it into a dynamic transformer rating, for instance, to reduce the maximum hotspot temperature they can go with the transformer. These are the important topics there. And for vibroacoustic, if we come back to the vibroacoustic, that's the first step what we have now on the market, and it's a very, very innovative tool for to add the conventional torque monitoring on the tap changer. That's the brand new point here.
Yeah, so to summarize that, the trend is very clearly that with the solution of the sensor family, the intelligent sensor family we have generated here, towards a condition-based maintenance, and also to a condition-based operating model. So that will be then the next step we can expect.
Yes, of course you can combine it, compare it like a digital twin of a transformer, to have an overview about the condition of each main assembly part of the transformer in like a digital twin, and get the information for the asset management there.
Okay, thank you. Now the question is, how looks a transformer in 20 years from now? When we have a look on sensors, cloud integration, as well as maybe power electronics. So here I would also start more from the customer side. What would be the expectation how a transformer should look like in 20 years from now?
Looking backwards, transformers haven't changed their shape and principles for the last 50 to 60 years. So it shows that the core part of the design is a very reliable and also very robust product. So I would not expect the core of the transformer to look completely different in 20 years from now, because there's so much proven elements in it, and we are in a very conventional environment, so that my expectation to changes to the core of a transformer is somewhat limited. But I think the surroundings of a transformer, the embedment into a digital substation as a crucial element of the functionality of the grid, that will probably be much different from today. So there will be quite a full digitalization, not just of a digital twin of the single asset of a transformer, but a complete digital twin of the grid, which allows pre-switching simulations to avoid, let's say, unnecessary weakening of redundancy, and which ultimately allows higher utilization of the grid. The utilities are working currently, because the time constant to build new lines is very long because of permitting processes. So what they are trying is to get higher utilization of existing lines. You could compare that with using the emergency lane on a highway in peak traffic hours, and the transformer will play a crucial role here to facilitate this over different voltage levels. So, but to allow that kind of operation, the transformer need to be more transparent, more digital visible and embedded in the grid operation, and I think that will be my vision from a former grid operator's point of view, how the transformer will develop.
Yeah, Karsten, then, what's your view on that? Maybe more in the direction also of the utilization of power electronics.
Yes, it depends on the grid of the future. I would say what we will find in a medium voltage range, for instance. In my opinion, we can start with solid state transformers, for instance. That would be one topic, maybe, because you can have on the same footprint of a transformer 10 times more transition power. And it is a medium frequency transformer as a solid state one. And that would be an interesting topic for the next years for megacities, for instance, what he has also in a discussion before. And it depends also from the volatile power infeed from the renewables. Maybe we will have fast switching devices in the network, solid state transformers, solid state tap changer, for instance, also possible. But it depends on the load and on the infeed of renewables, what we will have in future in the network. The customer and the utility must say what they want to have in future in the network. Yeah? But the technical issues are on the desk at the moment, and they are discussed, and we are prepared for the next generation of the transition network.
Yeah, to summarize that, so the transformer as such is still a dominant design. So also when we're talking about a solid state transformer, we will still have with the medium frequency transducer something what will have minimum 2 coils and a core, whatever that core looks like. So as we know that from a conventional transformer, whereas we will see tremendous changes on the boundary conditions by having the sensor integration, by having the data integration, and especially also the utilization of the data, as we mentioned already, for operation and for asset management. So what I would like to get from you as a very short answer, what is your personal take-home message from the MSENSE digital event? Wilfried, maybe you can start with a short answer.
Yes, it's. I think my takeaway is traditionally we launched this product families on trade shows, CGRE or IEEE events and sessions. We have to do this now for the first time in a digital way due to the COVID pandemic. I hope this is going to be historically soon behind us. But I think it offers also benefits which we will carry on in the future, because it offers our clients to follow our sessions at their convenience, at their homes, whenever they feel for it. So I think that efficiency and convenience levels will survive, even if we are hopefully soon back in the normal time when we can also meet again at personal interactions. So I think we will, in the future, have both the traditional way of meeting and presenting our products and these digital events.
Carsten.
Yes, we have seen a lot of innovative sensors now in the last 2 days. The new bushing monitoring system, the MSENSE DGA sensors, also for the high sophisticated level of DGA. And the vibroacoustic, of course, the worldwide first introduction of the vibroacoustic monitoring module, which offers new perspective to data mining, for instance. And from my point of view, we are very good prepared for the task of the new network requirements what we get from our customers. And I think we are very good on the right track for Ethos also to bring these tools into the network to satisfy our customers, to get the right information, to bring it in the substation control, and to have the right product range for the next time.
Excellent. So that leaves to me to have a final summary from my side. So we at the Reinhausen Group, we don't stop thinking, and will extend also to new dimension of digitalization. And I would like to ask Wilfried to give us a final summary and closing remark from the MR digital event.
Thanks, Uwe. Yes, this brings us to the end of our first digital event, which this time was completely in the spirit of sensor technology on power transformers. We created a ring around the transformer of sensoring, protecting the transformer from any hazards and damages. I hope we were able to really give you a good understanding of the benefits and working principles of the transformers and the functions of the different sensors. All the sessions have been recorded and will be made available to you offline. You and your colleagues are, of course, invited to our Customer Creation Center, from where we are taking this video here in Regensburg, Germany, and we are open for business and looking forward for that. Our colleagues are expecting and ready to answer your questions, and contact details can be on our homepage, reinhausen.com. We expect to continue our innovations, of course, and enhance the ring of products, same like we enhance the ring of around our MR letters in our logo. Please stay tuned. Finally, I would like to thank our team who have made that event possible and, from my point of view, already a success. The colleagues in our organization team for the pleasant surroundings. The colleagues from the marketing and IT to make this a truly extraordinary event and create the perfect technology around us to allow this reliable transmission. Our competent speakers and technical experts who hopefully gave you very interesting contributions and insights in the technology and our further way forward, so that the lectures were interesting and hopefully also easy to digest. Thank you to you customers for your interest, your attention and time spent to our event. Should you still have specific questions, our chat channels remain open for a further while, and of course our sales colleagues globally are always available and even happy to answer your questions and get in personal touch with you. Finally, thanks to Peter Schelte for the fresh and cheerful moderation over the last 3 days. Thanks a lot.